In this video, I'd like to discuss why water is so important for life. Basically, as far as we know, life absolutely depends on water, at least life as we know it. So if you look on Earth, anywhere there's water, there's bound to be life. In fact, your body is about 60% water by weight. Before we delve into some of the properties of water that make it so special, we need to get a few terms out of the way. The first term is solvent. A solvent is a liquid in which other substances dissolve. Another term is solute. A solute is a dissolved substance. So let's use an example. Table sugar, which is sucrose, which you can see here in the diagram, is a solute in water. If you put some table sugar into water and mix it up, the sugar is the solute. It's dissolved within the solvent, and the solvent is water. Together, you have a solution. So a solution consists of a solute dissolved in a solvent. So again, we could use the example of table sugar or sucrose. You have a sucrose solution. You have sucrose, the solvent, dissolved into water, the solvent. So let's talk a little bit about why water is so important. Well, one thing that's special about water is water molecules are polar. And like molecules tend to dissolve well or play well with other similar molecules, like molecules. So polar molecules, such as sucrose, will dissolve very easily in water. So let's take a look at the sucrose molecule. See, there's a lot of oxygen bonded to hydrogen through covalent bonds. Actually, if you look at this sucrose molecule, I should say something that you might not know. Whenever there's a junction where the lines come together, there's actually a carbon atom there. They just don't put the C there just to make it less, the diagram less busy. So that's a fairly typical way of showing a sugar such as sucrose. Was along the backbone of the molecule, you just simply, it's implied that the carbons are there. Nevertheless, you can see what I really want to point out here is the oxygen bonded to hydrogen. So those are very different in terms of their electronegativity values. Oxygen is much more electronegative than compared to hydrogen. So wherever you see that, we can be pretty assured that the oxygen is going to have a partial negative charge and the hydrogen will have a partial positive charge. So note that that's very similar to an water molecule. And because of this, sucrose will dissolve very easily in the water. So polar molecules are said to be hydrophilic. So hydro means water or hydrogen. In this case, we're referring to water. And philic means having an attraction or love of something. So we could say that sucrose is a hydrophilic molecule because it loves, in a sense, water. It dissolves very easily in water. So other types of substances dissolve very easily in water, and these are very important substances. So ionic compounds dissolve in water. So salt, which is, the sort of salt you'd find in any kitchen, is NaCl. If you place some of that in water, it will break apart into individual ions, and the term is dissociate. The scientific term is dissociate. The ions will dissociate, as you can see in this diagram here. NaCl, which has an ionic bond between the sodium and the chloride. The sodium, of course, is positive. Chloride is negative. When you put those in water, they dissociate, not completely, because there's some tendency for the sodium and potassium chloride ion to reassociate. But in general, most of it will be dissociated in water. And as you can see in the other diagram, as the sodium and chloride atoms come off of a grain of salt, the salt crystal, the sodium ions will be surrounded by water, and the chloride ions will also be surrounded by water. Okay, so and so this means that these ions are very hydrophilic. They're attracted to water, water's attracted to them, and so forth. And finally, I want to talk a little bit about the term electrolyte. So again, I mentioned this in a previous video, but an electrolyte is a solution containing ions that are electrically conducting due to the movement of ions rather than the movement of electrons. So there are a lot of sports drinks out there that are considered to be electrolytes because they have ions such as sodium, potassium, and so forth within them, and those are generally good ions to have within your body. Let's go on and talk a little bit about nonpolar molecules. And the example I'm going to use is canola oil. These molecules are not attracted to water. So a nonpolar molecule such as canola oil does not dissolve easily in water. And what I did here was I took some water, mixed in some blue dye with the water, and then I added some canola oil. And you can see that the canola oil separates away from the water. So this means the canola oil is hydrophobic. Hydro again means water or hydrogen. In this case, we're referring to the water. And phobic means fearing. So a nonpolar molecule is hydrophobic. It fears water, and therefore it stays away from water. Now, it may not seem that these are important concepts, but they really are very important. We need certain things such as polar molecules that will dissolve well in water. We need other things such as ions, electrolytes that will be dissolved within your blood, and actually the fact that there are no nonpolar molecules are very important within your body that actually are water fearing, and actually that's a very important part of the properties of these molecules, which we'll talk about in other videos.